we talk about foam systems and where they are used. The foam systems are consisted in different parts, like foam concentrate. So the foam concentrate is basically a soap that we are combining with like a liquid soap. Hand washing soap is a similar material. So we are combining with water with some proportioning. For example, for 3% proportioning, 97 liters of water is mixed with 3 liters of foam concentrate. So it becomes, by using a tank and proportioner, we have a foam solution. The foam solution includes some percentage of foam concentrate and more water. So for the 3% proportioning, we have 97% water and 3% foam concentrate. And we keep this foam concentrate inside the tank. And when they pass through the proportioning device, it picks up the necessary amount of foam from the system and mixes with the water and sent to the discharge devices. These discharge devices are special equipment that picks up the foam and combines with air, and it finalizes with the foam. Not a solution anymore. The solution is water and concentrate, and then when you mix with air in the end with the discharge device, it becomes foam in final shape. So it becomes bubbles on the discharge device. And we have two important information which is makes the foam for fire protection is expansion ratio and drainage time. These are technical information that we have normally in our technical trainings, but it's important to know that this is not a normal soap, not like standard bubbles. These are tested with the fire situations in different fire scenarios and different applications, and they have a very special expansion ratio and drainage time that we call the stability of the foam. So you cannot use any soap for foam systems. So where do we use these foam systems? Typically almost in all industrial plants that we have flammable and combustible liquids like diesels, like paints, like solvents, like the other chemical fluids that can be flammable and combustible. So when you have a fuel tank and it's burning, it's very hard to control its fire. So we have a system which is high performance with the foam system. We have foam tanks and a specialized center controlling the foam system. And it works as using the detectors in the system, flame detectors or fire detectors, informing the system that we have a fire in the facility. So in the related section, the deluge valve, as I showed you in previous slides, works, opens and sends the water on the pipe from the proportioner. And the proportioner mixes the foam in necessary quantity and sends out to the discharge devices over the tanks you see. And in the tank rim area, as we see, the fire is controlled very fast with the foam system in the related area. So these devices are specially designed for these kind of tank protection, and it has special items to expand the foam into a protection foam. And there is also some kind of dikes besides the tanks, and on top of the tanks, closed tanks, we have different devices like foam chambers that is expanding the foam in necessary amounts. And also in long distance throw, we have monitors. When maybe some of you have seen in the movies, monitors, and also in the loading racks and trailer areas, we have deluge sprinkler systems, foam systems, and also for the vessel protection in the piers, we have monitor towers with the foam systems. And also in aircraft hangars, we have different type of systems on floor level. On floor level, we have grate nozzles integrated onto the floor of the hangar that eliminates any kind of flammable and jet fuel spill fires and controls the fire in a very fast manner. And also we can use monitors in the hangars. Monitors are automatically oscillating monitors like we have in the fields for watering the plants, but it's for fire protection. For also hangar protection, we have high expansion systems that's expanding the foam to almost 1,000 times of its original volume. So it's filling up some height in the hangar or in the storage rooms. And also the foam systems are used in the waste energy plants, waste storage plants, and there are special detection systems like thermographic camera systems that is pinpointing the fire point and directs the monitors to this position like robots. And in waste incinerator plants, we have big pits of waste going to the bunker and for the burning and energy production. And there are also installed electrical automatic monitors with thermographic cameras detecting hotspots and activating the system. So it's in general the applications of foam systems in different types of industrial and infrastructural facilities. And I will show another example with a deluge system, which is called high expansion systems. The operation of the system also will be a little bit explained.
In this scenario, we are looking at a Group 2 aircraft hangar. The hangar is protected with an electric release deluge foam system supplied by a bladder tank. A bladder tank is a device that is continually pressurized by the main water supply. The water sits between the steel shell and the rubber bladder. The bladder is filled with a foam concentrate. The bladder tank concentrate piping leads to the concentrate control valve that is held closed by priming water. The concentrate control valve is holding back the foam concentrate supply until the system is activated. Continuing past the concentrate control valve is the ratio controller. A ratio controller is a proportioning device that meters foam concentrate into a water stream to create a foam water solution, typically at a 3% ratio, depending on which foam concentrate is used. Upstream from the ratio control valve is the F1 deluge valve, which has a shared priming connection with the concentrate control valve. This allows the two valves to activate simultaneously. The deluge valve is holding back the main water supply until the system is activated. In a scenario where a fire has started in the hangar and begins to grow, the electric detection device activates and sends a signal to the VFR 400 release control panel. The electric solenoid valve is powered open, releasing water pressure within the priming chambers of the deluge valve and the concentrate control valve. The drop of prime pressure causes the priming line pressure switch to activate. Priming line pressure switches are required for factory mutual global approval. After the release of prime pressure, the deluge valve's clapper and the concentrate control valve's clapper open simultaneously. While the next steps happen in parallel, we're going to look at the water side of the system first. Once the deluge valve is open, water will fill the trim and activate the water flow alarm. Water will enter the system riser, passing through the ratio controller. Occurring at the same time on the concentrate supply, the foam concentrate is under pressure in the bladder tank. Priming pressure on the concentrate control valve drops, and the concentrate control valve opens. Foam concentrate begins to flow towards the ratio controller. The foam concentrate will pass through the metered orifice and then mix with the water into a foam solution. Let's back up and show these steps all happening together as they would in a normal scenario. The foam solution travels to the foam discharge devices, and the fire is extinguished.